Okay, question 1. A car starts from a rest and drives in a straight line. A graph shows the distance from the start for the first 5 seconds. Use this table of values to make a copy of the graph. Draw a tangent at x equals 2. Okay, so at x equals 2 at this point here, it's not very clear because it's not very large, the graph. Now bear in mind that we are dealing with a curve here. This distance time graph is not a straight line, it's a curve. That means we don't have a fixed gradient, we have an average gradient. So if we take any 2 points on this curve, the gradient between them is an average gradient because the gradient is constantly changing. So if we just plot another point up here, let's just call this point here A and B. The average gradient, if we draw a straight line between A and B, now that straight line clearly doesn't represent that curved section between A and B. That curved section between A and B shows that the gradient is constantly increasing between A and B. If A had to approach B, then we'd always have a tangent line at every single point. And that the gradient of every single tangent line would be changing. The gradients of each tangent between A and B to the curve would not be the same. So that's why we call it an average gradient. AB, if a direct straight line, would have a fixed gradient, but you don't have a fixed line, we have a curve. So it's called an average gradient. And that's what the concept of drawing a tangent to a curve represents. It represents an average gradient. So now we're going to estimate the speed after 2 seconds. Now to do that, we are just going to draw a triangle underneath the tangent line. So because it looks like the line cuts the x-axis at 1, we're just going to draw a triangle like that. So we're going to use this blue triangle here to estimate the gradient of that line. So the gradient of the triangle will be, now if we just read off that y value there, each division is 2, so that's going to be 8. So y2 minus y1 will be 8 minus 0. And then x will be x2 minus x1. So it will be 2 minus 1. So that equals 8 over 1, which is 8 meters per second. So the estimated speed after 2 seconds is 8 meters per second. Okay, so we've drawn a tangent line at x equals 4, and if we read that off, it looks like it's at that mark over there, which is 32. So if we draw a triangle now, and again, this is just an estimate, right? So let's just take this point over here. Let's just draw a triangle there like that. Because it's an average gradient, it's an estimate, right? It's not going to be exact because we're dealing with a curve here. So the estimated speed is going to be the gradient. So it's going to be this over here, which is the change in y, which is 32, and this mark is 20. So it's going to be 32 minus 20 over, and this is 4, and that is 3.2. So it's 4 minus 3.2, which is going to be 12 over 0.8, which is 15 meters per second. Question 2. A tennis ball is hit straight upwards. The table shows the height of the ball. Use the table to draw a graph of the height of the ball. Okay, so the height, we're going to draw, we'll do this accurately now. The x-axis will be time in seconds, and the y-axis will be height in meters. Okay, so we're going to plot this graph, and once we've done that, we're then going to answer the questions. Okay, once we've plotted all those points, draw a smooth curve through all of those points. You do not use a ruler. There are no straight lines between points. It is a smooth curve. So draw it as accurately as you can with your hand, but it has to be smooth. There are no edges, there are no straight lines. Okay, we are now going to draw a tangent to estimate the speed after 2 seconds. So after 2 seconds, we're going to draw a tangent line at that point over there. Okay, so remember that we're dealing with a distance time graph, right? Height is a vertical distance. So the slope of a distance time graph will give us speed. So that's what this tangent line is going to give us, an estimate speed. So we're going to determine the gradient. To do that, we are going to draw a triangle. So let's just take this point up here, because it's still on the graph, and just draw a triangle there. You can call that point A, point B, and point C. So the gradient of AC will give us the estimate speed. C is the point, x first 350. B is the point, 340. A is the point, 240. Now, so the gradient of AC, we can either use the points A and C, or we can just work out to take the vertical distance and divide it by the horizontal distance. At least the vertical, not distance, the vertical divided by the horizontal. So the gradient will be BC over AB. So BC will be 50 minus 40, okay, which is 10 units. And AB will be 3 minus 2, which is 1. So it will be 10. The gradient of AC will be 10. In other words, the estimated speed at 2 seconds is 10 meters per second. Draw a tangent to estimate the initial speed when the time equals 0. So we go back to the graph, and now we draw a tangent line where x equals 0. Again, we're at 0 now. Let's draw a triangle. Let's use this point over here. This will be our triangle. The height, the gradient of that line over there, can call that ODE. The gradient of OD, the height will be 35 minus 0. So it's going to be 35. And E is at 1. 1 minus 0 is just going to be 1. So it's going to be 35. So the estimated speed at the origin is 35 meters per second. Now you'll notice that with this is a quadratic curve, right? This OD is a much steeper line than AC. And it makes sense because the steeper the line is on a distance time graph, the higher the velocity. The steeper the graph, the higher the gradient. The speed after 5, what is the speed, sorry, D, what is the speed after 3 seconds? So after 3 seconds, to determine the speed, because we're dealing with a distance time graph here, the gradient of a distance time graph gives us the speed. So if we draw a gradient, sorry, if we draw a tangent to the curve at t equals 3, it's a horizontal line. Now, a horizontal line has got a gradient of 0. So what that means is that at t equals 3, the speed is 0 meters per second. The gradient of a distance time graph will always give us speed. The gradient of a horizontal line is always 0. So therefore, at the apex, at the top, the maximum height of the curve, we're going to have a speed of 0. Estimate the speed after 5 seconds. So let's estimate. Let's try to draw a triangle. Let's take this point over here. We'll draw a triangle to that point there and then across. Again, you need to use your judgment in sketching a triangle, right? So try to find points where the values are almost exact on the curve. So this is the triangle that we're going to work with. Gradient of MP is going to give us the estimated speed at P. So look at Mn. This is 45 minus 25 over, we're talking about the gradient here, P minus N. So it's going to be 5 minus 4. It'll be 4 minus 5. It's 4 minus 5 because the line is going to be the slope is going to be negative. So it's going to be 20 over minus 1. It's going to be minus 20 meters per second. The minus just means that it's in the opposite direction of original motion.